the average rate of change of a function. So our objective, find a nonlinear function's average rate of change. You'll notice I paused on nonlinear. Obviously, a linear function, a line, the average rate of change is always the same. But we're going to talk about a nonlinear change when we have curves. And in these situations, we're going to have an average rate of change because it's on a curve, it's always changing. But what is the average rate of change between 2 points? So we know a couple things here. The slope is a measure of a line's steepness, calculated as m equals change in y over change in x. Shorthand, m equals delta y over delta x. And rate of change is a change in the y, positive or negative, divided by 1 unit of x. Okay, as we spoke to, the graphs of most functions are not straight lines. So in these non-linear cases, we look at an average rate of change, okay, between 2 points. And we're going to use a secant line. A secant line is a line which intersects 2 or more points on a curve. Okay, let's take a look at this pictorially as a picture. Using function notation, we define, so we have an x and our y is now f of x. We define the average rate of change as f as follows, as opposed to y1, y2, okay, excuse me, let's try that again. As opposed to y2 minus y1, we'll replace that with f of x2 minus f of x1. So our 2 points are x1 f of x1 and x2 f of x2. So the change in y is this minus this, or the change in x is this minus this. So here's the picture for you. Here's a function, it's curved like most functions are. And as you can see, the slope is constantly changing because it's a curve. For those of you going to calculus, you'll do a lot of work with this. And so we're thinking, well, my goodness, from here to here, what's the average rate of change? I mean, it's always changing, but what is the average rate of change between those 2 points? Well, we draw a secant line between those 2 points, and we calculate the slope of that secant line, and that gives us an average rate of change of what's going on with going on between these 2 points, despite the fact it's a curve. Okay, so let's remind ourselves, we know that we've been working with slope as change in y over change in x. Well, as opposed to y, we're going to use function notation. Okay, that's all we're going to change. We're going to change it to function notation and look like that. Okay? Okay, let me get my other piece of paper here, get my notes together. Okay, just a second. All right, fine, I think I'm good. Find the average rate of change of the function f of x equals x squared from x1 is equal to 1 to x2 is equal to 2. Okay, so from x is 1 to 2, what is the average rate of change? Well, x1 is equal to 1. Okay, f of x1, if I put 1 into the function, okay, is equal to x squared. So I'm going to square the 1, which is equal to 1. Okay, so I know this point is the point 1, 1. All right, this is the point 1, 1. Now let's do x2. Okay, and I'm saying that x2 is 2. Okay, what is f of x2? F of x2 is the same as f of 2, which is 2 squared, which is, of course, 4. So this second point is the point 2, 4. Okay, so what is our average rate of change? Well, we know is the slope is equal to change in y over change in x, but in our function notation, f of x2 minus f of x1 divided by x2, yes, minus x1, and that is going to give us, let's see, f of x2 is 4, f of x2 equals 4, f of x1 is 1, so 4 minus 1, x2 is 2, x1 is 1, and so I used this, but I could have used these points, 4 minus 1, 2 minus 1, and I get 3 over 1, which is 3. Okay, so let's see what's going on here as we find the average rate of change of a function. Okay, I'm going to try to draw this, and I'm going to draw it a little bit exaggerated so we can see it. Okay, so this is the x-axis, a little bit exaggerated. So here is, okay, this is, well, this is f of x equals x squared. Now I know it also goes this way, so I know that's the x squared function in a graph. Okay, so let's take a look. Let's call this is when we have 1, and I know my graph is off, but this is the point 1, 1. Okay, and I'll put 2 here so we can really see it, and I'll put this up here, and this is the point 2, 4. Okay, 1, 1, 2, 4. Again, my graph has been exaggerated to help you see it. What is the slope between these two? Well, the slope is always changing on a curve, but if I draw the secant line, there's my secant line, I can find the slope of that line. All right, the slope of my secant line is 3. So I know that the average rate of change from 1 to 2 is up 3 over 1. Now we know that's not true because for every piece, because these slopes are always changing because it's curved, but it's true as an average between 1 and 2, the average rate of change is a slope of 3 or 3 over 1. Okay, let's do another example. I won't do the drawing for this next one, but I'll do the example so we can see it. Find the average rate of change of this function, it's the square root function, from 81 to 36. Okay, so from 81 to 36. Okay, well, we know that x1 is equal to 81. Okay, well, let's find what f of x1 is. F of x1 is equal to f of 81, which equals the square root of 81, which equals 9. Okay, and x2, we're told is 36. We need to come up with the y coordinate for the x coordinate of 36. So what is the y coordinate of x2? Well, it's the same thing as the y coordinate at 36. And the function says take the square root of 36, and that, of course, is 6. Okay, so our slope, we know our slope is the change in y over change in x. In function notation, f of x2 minus f of x1 divided by x2 minus x1. Well, f of x2 is 6. F of x1 is 9, so 6 minus 9 divided by x2, which is 36, minus x1, which is 81. And I believe this gives me a negative 3 divided by a negative 45, which gives me, I hope this gives me a, let's see, oh, yes, that's correct, which simplifies to 1/15. Okay, so the average rate of change between those two x coordinates is 1/15. Okay, so there you have it. Average rate of change for nonlinear functions.